Okay, let's move on to serial correlation. What is serial correlation? What is autocorrelation? Anybody? You heard about this term. What is autocorrelation and what is serial correlation? Both the terms are same or different?
Serial correlation is over time when variable is related to its own values.
Both are the same, huh? Actually, we are using this terminologies invariantly. There's a slight difference between these two terms. Correlation, if you're comparing the error terms between two different variables, X and Y. Whereas serial correlation will check the correlation among the error terms within the variables itself. Okay, there is a small difference. Even you can find this in Gujarati, but technically we use serial correlation or autocorrelation all similar. So
Repeat. Please repeat.
for example, you have a variable called X, you have a variable called Y. You have error term for X, you have error term for Y. Okay, if you're comparing these two error terms, it is called as autocorrelation. Serial correlation is you are checking the correlation among the error terms with its own past lagged values. This definition is in Gujarati. You can go and check. Okay, even he himself mentioned that there's a slight difference, but we are using invariantly. So serial correlation. See, in the panel data analysis, we are not going to see something new. Whatever apply in the time series, we are going to do the same here. If you are applying any regression model, whether it is a panel data or time series data, whatever it may be, if you are applying any regression model, we are always having certain set of issues. We try to address those issues. As I told you in time series econometrics, if you are trying to estimate the parameters of any regression model, we are supposed to make sure that the estimated parameters satisfy a set of conditions called as classical linear regression model assumptions, right? The first two assumptions, forget about first two. The basic assumption is certain set of assumptions talks about the error term, how the error term must be distributed. Certain assumptions talks about how the relationship between error term and the exogenous variables must be. Certain assumptions talks about how the exogenous variables are supposed to be have a relationship among themselves, right? In this scenario, if you apply any regression, whether it's a time series regression or panel regression, you have to make sure that the set of issues will be sorted out. Okay, even though in this 13 or 14 assumptions, as I told you in the last session, there are 4 serious assumptions are very, very important. First one is homoscedasticity. Okay, homoscedasticity, if this assumption is not satisfied, if it is violated, then we have the problem of heteroscedasticity. You know all about this thing. Then a condition of multicollinearity. Multicollinearity will apply for in a set of variables more than one independent variable. Yeah, more than one independent variable. Then we have other condition called as errors in variable. That's what we discuss. Errors in variable talks about exogenous variable. I think all of you know about what is exogenous variable, endogenous variable, explanatory variables, independent variable, and dependent variable. Generally, we used to use independent variables and exogenous variable and explanatory variables are similar, but there's a slight difference among themselves. Okay, if you say something is endogenous variable, even though it is independent, it is supposed to possess some characteristics. If you call some variable as exogenous, even though it is independent variable, it is supposed to have some characteristic. Okay. It all depends upon where you're declaring. If you're using only 2 variables, then we can call it as dependent variable and independent variable. If you're going for a set of equations, a simultaneous equation kind of model, then you are supposed to declare it as endogenous variable and exogenous variable. What is the definition of endogenous variable? I'm talking is not relevant, but still you can learn it. Endogenous variable is something if a variable acts as a dependent variable in one equation, at the same time it acts like the independent variable in some other equation, then those variables are called as endogenous variable. So what's the point? A variable act as a dependent variable in one equation, maybe in a system of equations. The same variable act as a independent variable in some other equation, then we used to define it as endogenous variable, not independent variable. Getting the point? So this point we need in the next slides, but anyway. So among this, the one serious problem is correlation, serial correlation. Okay. What is serial correlation? In simple terms, we used to say that if the error term, particular set of thing, which is not so, if the error term of the particular set is correlated with past lagged values, then it is called as serial correlation. Otherwise, in simple terms, we have a problem, something called as autocorrelation or serial correlation, when if the error terms are correlated with its own past lagged values. If the error term are correlated with its own past lagged values, then we have a problem of autocorrelation. Generally, That equation is not here. Anyway, I can show. Not working, man. Not working.
That right? Right.
Yes, well, it's working now. Perfect.
Different variables and terms in their coordinates.
So serial correlation. Actually, I'm not in the equation here. Maybe I can write it here. The simple definition is error, when we talk about serial correlation, autocorrelation data, error terms. Working. So, generally, what is the definition of autocorrelation? As I told you, if error term of a particular period is correlated with its own past lagged values, then it is called as autocorrelation. I'm using the term autocorrelation and serial correlation invariantly because sometimes you may get confused, right? So here, let me use the term serial correlation or autocorrelation, whatever it may be. So when it comes to panel data, the same logic apply here. Definition is error term of a particular entity. So for example, a particular state is not supposed to be correlated with its own past lagged values with different time periods. For example, let's assume we have 5 years of time periods starting from 2020 to 2025, right? Then we have, let us assume 5 states, Southern Indian states. What this serial correlation says is that the error term of the year 2025 of state Tamil Nadu is not correlated with the error term of Tamil Nadu in the year 2024. Okay. Likewise, it is not supposed to be correlated with the error term of 2023. The same entity, Tamil Nadu, the error term is not supposed to be correlated with its own past lagged values. If it's happening, then we have the problem of autocorrelation or serial correlation. The condition is I missed the equation here. The equation is supposed to be like this. Means don't get panic because equations. There's nothing but the error term of entity. So listen here. Let us assume a state Karnataka. Error term of Karnataka at time period 2021. Suppose this is nothing but the error term of Karnataka at the time period 2022 is not supposed to be correlated with each other. If it is not the same, if it is equal to 0, then we don't have the problem of autocorrelation. If it is not same, it's not this condition not satisfied, then we have the problem of autocorrelation. It is serial correlation, right? So what are the reasons we get serial correlation? Okay. First thing is, let me start from omitted variables. See, you all know that there is a shock might have happened. If you take an example of COVID, right? You modeling that any variable, if you're not including that variable, the impact of that variable will be transmitted to some other variable. Okay. There may be transmission of trending pattern over a period of time. If you are not incorporating that, that may lead to influence of error term on other periods. Second thing is persistence of shocks. There may be a shock. If any shock has happened, if you talk about COVID, what happened in 2020, it has still impact on certain areas. Even maybe in health sector, there is a serious debate. People are saying that those who passed away at young age because of COVID impact. So some shocks will happen, but that thing will be transmitted over a period of time. If that is the case, the error will be correlated. Then model misspecification and wrong functional form means you all know that there is different types of functional forms are there, right? In very simple terms, we assume that there is a linear model and non-linear model. In the linearity model, we have 2 different types of model. One is linear in parameter, another one is linear in variables, right? So suppose if the model is, I think during COVID time, we are talking about U-shaped recovery, right? When you heard about this term, U-shaped recovery. So this initial point of time, our growth is coming down. It's keep on increasing. People are talking about W-shaped recovery. Initially falls, increases, then again come down, again goes. Okay. So this is nothing but a model. I'm not discussing much, but for make you understand the concepts I'm using this is nothing but something called as linear trend. What is that? The time is increasing, the variables keep on increasing. What's the difference among these things? Here, the trend is constant. The time increases have the same pattern, whereas here it is not the same thing. So if you want to model this, you can use a linear model. But if you want to use this, you can't use a linear model here. Right? This is the only thing, man. I'm not going to use much. For example, if you want to estimate this, you can use going to be a linear model. Both the things are parallel, but you can't estimate this function with this model. It's supposed to be maybe y square. It may, if this is the case, it is going to be linearity in variables. This thing is going to be linear and non-linear in both variables as well as parameters. If you want to model this here, but if you are using this equation, get the point. Real relationship of the variables is like this. Y index is initially y falls, y increases, x falls, then it's picked up. But for measuring this, you have to use a model in this criteria. Instead of this, you are using this. What happened? You end up with autocorrelation problem. Right? This is called as functional forms of the equation. This is nothing but a non-linear function, it's a linear function. The non-linear function may be parabolic, cubic, a lot of functions are there, right? So it depends upon that, you have to define your equation. So simple terms, if a model, if a relationship between the variables belongs to linear form, but instead of that, you are applying non-linear form, then you are going to end up with the problem of, not only this, you are going to end up with severe problem. This is called as model misclassification or wrong functional forms, right? How many variables we know? There are certain variables which is influencing your, take our example of our heterogeneity. There are certain levels of heterogeneity which will cause your dependent variable, but you are not incorporating it, means that effect will be captured in the error term. So that will be keep on transferring one period to other period, basically up with correlation among the error terms, right? Measurement errors in the sense, suppose if you are measuring, there may be a problem in measuring the variables. Certain variables may be in numbers, certain variables may be in tons, certain variables may be in kilograms. If you are instead of measuring in numerics, if you are measuring in tons, then you end up with the problem. So these are all the common problems you are facing while dealing with any analysis part. So why serial correlation matters? So if there is a, I told you very beginning itself, you can call, what are the purpose? Okay, maybe I will start in this way. The purpose of all estimations, the purpose of all our research is twofold. Maybe one may be forecasting, one may be maybe policy conclusions, right? Why you are doing all the analysis, why you are spending so much of time, why you are breaking our heads, why you are spending hours and hours of time in the system, why you are estimating all these things. The purpose may be twofold. One is you want to forecast from the model. You have to make a forecast from the existing thing. Second thing is you want to prove or disprove something. That is the case. So if that is the case, how do you decide? You can't forecast a model which is not reliable, right? You are using a wrong model for forecasting, your forecast is going to be wrong only. So in that case, you have to make sure that you are picking up the appropriate model for forecasting. How can you decide a model is appropriate? How can you decide a estimated model is good enough for forecasting? It all depends upon a lot of criteria, as I told you, a lot of parameters. One among the parameters is that model must be having the problem of autocorrelation, serial correlation. Not only this, it must satisfy all our condition of classical linear regression model. Apart from that, it must have a high R square, it must have a high R bar square, high F statistics, low retrievability statistics. There is a lot of parameters out there. Not only one parameter, is one among the parameters. So if you want to pick the best model, you must make sure that that model is not having the problem of correlated errors, right? If that is the case, you can't use that model for any purpose. The first thing is I'm not being here, but that is the first point. Second point is, if you are talking about error terms, what we are talking about correlation among the error terms. This is not having any impact on your estimated parameters. If you're estimating a model with autocorrelation, it is not affecting your alpha and beta values. Never affect your alpha and beta values. But it affects the standard errors of it. I think all of you know about what I mean by standard error, p-value, and t-stat, right? Everybody estimated this. What is meant by p-value? Probability value is fine. What is the purpose of it?
Statistical significance.
It's statistical significance. Yes, p-value is a measure of statistical significance. But what is the purpose? What it serves actually?
It's the exact percentage that these are the chances of error that our results will.
What error?
And
This p-value is nothing but it will tell you what is the chance of committing typo error. What is typo error then?
reject.
You have lots of parameters. Yes. What's typo error?
Rejecting null when it's true.
This is criteria. If the hypothesis is right, but you reject the hypothesis is right, what is the chance of rejecting it? Typo error is the hypothesis is wrong, what is the chance of accepting it? So don't think that numbers are just simply p-value, that is fine. But what is the purpose? You have also something called as t-stat. What is the purpose of t-stat? You have something called as standard error. What is the purpose of standard error? You have something called as f-stat. You have something called as r square. R square you know, right? So each and every parameter delivers something, right? So as I told you, if you have autocorrelation problem, even though with autocorrelated errors, if you run the regression, you can get alpha and beta without any problem. Problem is autocorrelated errors affect the standard errors. Right? What is standard error? Standard error is a mechanism which will tell you whether you can accept that coefficient or not. Whether estimated coefficient, you are estimating beta and alpha, right? You estimate that. How can you decide whether this is statistically significant or not? That can be tested with the help of t-stat, p-values, right? And standard errors. If you have autocorrelated errors, that will affect your standard error. So the standard error may be inflated. That may leads you to accept the wrong hypothesis. That may leads you to reject the wrong hypothesis also. Are you getting the point? If you have autocorrelation problem, still you can estimate the regression model. You can get alpha and beta without any problem. The alpha and beta does not have any problem. But we are not going to end the story with only alpha and beta. We have to decide whether that alpha and beta is of statistically significant or not. How do we decide that? It is decided based on p-value, and then standard error. If you want, what is the formula for standard error? That is the formula. In that formula, standard error is computed with the help of error terms, right? If you have a wrong error, if the error term is correlated with the past values, standard error, what you are going to compute is going to be wrong. If you take decision based on that standard error, then the model what you are choosing is going to be also wrong. Right? That is the formula. How do we calculate standard error? Beta by standard error, if I'm right. That is the formula for, beta by error term. I forgot the formula. That is going to be the standard error thing. So if the point here is, if you have the problem of autocorrelation, you may get parameters of regression. The problem lies in the standard error, which will push you to the end to choose a wrong estimated coefficients, right? That's the problem. Second thing is overvalue t-statistics. Why? Because for computing t-stat also, you need these error terms, right? Because of the wrong error, the t-statistics may be wrong also. See, you are going to decide a person based on certain criteria. If you choose the wrong criteria, obviously you are going to end up with wrong results only. How do you decide this model is good or what? Based on the parameters, what I'm saying. To compute that parameters, you need standard errors, right? For computing those values, you don't want standard error, autocorrelation problem. But if you want to decide whether you can choose that parameter or not, for that we need errors must be free from the correlating between the past values. So if it is correlated, then you have the autocorrelation problem. That will affect your standard error. That will affect your choosing of the model. So incorrect p-values, all are serve the same purpose. P-value, t-stat will help you to decide what type of model, whether the estimated coefficient is statistically significant or not. Okay. Misleading inferences. It's obviously going to be the end results, right? Actually, this part because I thought that I don't have time, so I minimize it. I'm not giving you any equation, but I'll tell you the logic, how it works, right? If you need, maybe after this I can draw. So we all know that there are different types of models out there in panel data. I'm talking about very simple model. I'm not talking about any dynamic models. First one is pooled OLS. Last one, man. I'll take it. This. Here, this one. Fine. Yeah, fine. It's not in full screen. Is it fine now? Are you able to see it?
Yes.
Okay. Serial correlation. So we know that there is serial correlation. How do we deal with this problem in our data models? First thing is, we know there are different types of models out there. Pooled OLS, fixed effects model, and then models. In pooled OLS, you 100% sure that you can suspect autocorrelation. What happened? We are just simply estimating. We are assuming that there is no heterogeneity. We are especially leaving that variable. We are assuming that it's common, but it is not going to be common. See, all the issues are interconnected. It's not going to be common for all. There may be country specific or individual unit specific heterogeneity. We are excluding it. We are assuming it's constant by its own. So obviously, there is a high chance of committing autocorrelation problem in the model because of fixed effects, right? So pooled regression is just a regression, but that is what I'm saying. We have to be very sure about all the things. Second thing is fixed effects. We can expect the autocorrelation problem if the error term has the AR structure. You know what is AR structure, right? AR means autoregressive. It's a past term, right? It all depends upon basic understanding. If you know that the data itself have some lagged impact, then you may suspect that there may be a chance of autocorrelation in fixed effect model. What about random effect model? In random effect model, I told you that heterogeneity can be classified into two groups. One is constant. Do you remember that delta is Z? We can divide into mu and ui. So the mu may be constant, but that ei may be in the correlation with other things. So in pooled OLS, 100% that is going to be autocorrelation. Very high suspectable chance. Whereas in terms of fixed effects and random effects, fixed effects may have the autocorrelation problem if your variables are having any autoregression terms. Okay, but error structure have the past values. For example, you were checking about, you were talking about stock markets. You were monitoring that. Stock market is purely based on trends. It's based on the past impacts. So obviously, the current value depends upon there are some theories out there in the stock market, right? Like that, what is that? Racial expectation hypothesis, and then what is that? Efficient market hypothesis. Anybody come finance, they may know about efficient market hypothesis and then racial expectation hypothesis. It says that your current value depends upon some constant plus past values. If that is the model, then obviously you're going to have a correlation model. Whereas in random effect model, we are going to decompose the unobserved heterogeneity into two components. One is constant for all. The other component may have the correlation with the other variables. So if that is the case, there may be a possibility of serial correlation in some of its models also. So how do we address this? Okay, each and every model have a series of mathematics behind it. I'm not going to teach that mathematics because each and every model have different equations too. Okay, so what I'm doing is I'll just introduce the test name. Okay, computing these tests are very simple. Go and use in any packages nowadays. All these packages are available in the handy way. Without knowing anything, you just go and click that menu. Variable can be estimated. You can get the results. Okay, that is the. I'm ask a question. Maybe after this I can explain why that question is very important. So if you have a serial correlation problem, okay, here if you look at those things, you can identify if you're using fixed effect model, there are certain tests are there to check the serial correlation. Okay, if you're using random effect model, then there are different tests out there. You can't use the test which is applied for fixed effect model to random effect model. Suppose you want to check the existence of serial correlation in fixed effect model, then you can use Woolrich test. Okay, is it clear? If you want to check the whether there is a autocorrelation problem or serial correlation problem in the fixed effect model, then you can use Woolrich test. How this test operates, I have a lot of notes, but it will take a lot of time. Maybe I can give the name only. If anybody is very particular about this, you can write to me. I can respond. Any particular test on done? Like I have a lot of notes. See, a lot of papers are there, but it'll. I got to finish this half an hour back. Now still I'm. So I can quickly. Second thing is, suppose you have a random effect model. If you want to check what are the tests you are supposed to use, if you want to check for the presence of autocorrelation, then you have to use test called Balaji WLB test. Okay, these test names are available everywhere. Suppose your model is on a dynamic panel, you're using lagged structure itself. Both the tests won't work. You have to go for Arnold AB test. It's the most famous test in dynamic panel. Right? So it is all model specific. If you apply Balaji WLB test for fixed effects model, you won't get the best results. You may ask why. These models are designed in such a way to capture all the structural pattern of the particular model. It is designed exclusively for something. It is have a unique nature. Okay, it may give some results, but that results are not reliable. So maybe I can answer the question what Madam asked. Madam asked why people are looking for only data, not for e-views. Anybody can give a try. Why people are looking only data, especially on panel data? Maybe it is not. It is out of box, but still will help you to understand the process. Why? Why people are preferring only data, not e-views? How many of you are much comfort with the e-views? 2, 3, 4. Fantastic. So if it is not the case, others must have other softwares, right? What are softwares people are using?
Yeah.
Stata, Python. Right. See, what I'm telling you is not in any books. It's my way of expressing things. I have a paper. I designed a paper for my students, something called as data analytics using open source software, OSS. How some people are taking that. See, you can classify the econometric software into 3 broad categories, right? It is not in books, it's my understanding. First one is something called as menu-driven packages. Second one is something called as code-based packages, language-based packages. Third one is hybrid versions of that. Actually, there is no any special case for menu-driven. You can get both actually. So for menu-driven, highly menu-driven, maybe in that way I can use. Highly menu-driven means the software is e-views. Like Excel, everything is predetermined. If you want to run a co-integration, whether you or anybody, even the child, you add the data, by mistakenly you can estimate co-integration, ARDL, whatever it may be, right? Without knowing anything. Everything is there. There are certain packages where you're supposed to write your own codes. Okay. The best example for this is R. Even Stata, we have something here and there. Okay. There is one more package. I don't know how many of you know about it. There is one more package called as GAUS matrix, GAUS matrix. There is another package called MATLAB. There is another package. I have almost 70 packages which we can use here. SAS, SAS, these are all old packages, right?
Jamovi.
Jamovi is a menu-driven program. Jamovi, JASP is all menu-driven. It is not. Python is purely code-driven. There are third size of software. It is called a hybrid, a combination of both. Okay, maybe we can call e-views is a combination of both. I'll ask you a question. Which one is best? Hybrid.
Researcher is comfortable.
Which one is?
Yeah,
actually, obviously we are going for whichever is comfort for us. But your comfort zone always kills your learning. Yeah. If you want to be a good researcher, not only researcher, if you want to understand the subject properly, don't use e-views. Yeah. Write your own codes. If you want to understand the subject, without understanding what is regression, even you without knowing what is summation, you can't do any summation in R. You have to write a code for some 2 numbers even. So what skill set you're developing? You're developing the skill set of writing codes. Meantime, you're developing the knowledge of subject also. If you want to run a regression, you have to know what is regression. You have to know how you are supposed to define it, how it operates. Without knowing the operational procedures, if you want to get alpha, beta, and error term, you have to write minimum 10 pages of lines of codes. Without understanding your subject, you can't write any code. So if you really want to learn subject, the best way is write your own codes. Nowadays, even coding is not matters. Every codes are available. What you can do is you can extract the code and try to understand it, what people are doing. You don't need to write a code. Okay. Why e-views means it's very easy to work on, but at the same time, what to say? Results are still questionable in my experiences. I can share one small experience, then I can quickly move on. There's a model called as Bay and Perron. Some of you may come across it. That's a model which will use to capture the structural breaks in the equation. Generally, what we used to do, if you have some 50 years of data, we can go for historical breaks, right? We can go for a 1967 war, the 1980s first oil price shock, 1990 second oil price shock, 1993 economic crisis, 2003 2000 dot-com crisis, then 2007 subprime lending crisis, 2020 what is that? Corona. If you have 50 years of data, we used to go for historical breaks. But that model, Boy and Perron, itself find it. So going for arbitrary breaks, if you give the data, that model itself find the breaks and let you know. You can compare that. That is more reliable. If you want to estimate that Boy and Perron with the original codes, you have to estimate about 6 coefficients. Then only you can use that for your interpretation. Whereas EVs will give you only 3. But nobody knows how it operates. Okay, the minute-driven program, nobody knows how it operates. Even you can, but why I'm saying is this: to estimate that, we crack the code, we use a software called as Oxmetrics. Then we got it. It will take almost 6 months for us to crack that. But nowadays, we use 13 incorporate that. But if we estimate that, it will give you only 3 coefficients. With that, we can't interpret anything. Original paper, the author himself suggests 6 parameters to decide a model, but EVs is not doing so. So they make it very simple. Okay. Minute-driven, we don't know how things are operating. But here, it's a kind of homemade food and hotel food. Hotel food, we don't know what type of kitchen they are using, what type of ingredients they are using. If you order something, you will get something. And in home, you know what ingredients you are using, right? It's your food. So that is the first thing. If you want to really learn the subject, this is the time. Okay, once you enter the system, you don't have time to read. So dig your time. Start reading things from coding side. Okay, try to learn. No need to try to learn own codes also. Doesn't matter. Now the codes are available. At least learn how to understand the codes. Okay, if you know that, if you suppose you have the code of co-integration, you can understand subject, you can understand the coding, you can understand also how this operates. That's the important part of that. The question for you is, ma'am, EVs, you can't estimate beyond the numbers. Okay, suppose you are dealing with a panel data set of say 1 lakh observations. Use as the minimum numbers. Okay, beyond that, you can't declare. Whereas in the state and R and all, you can declare the memory. You can declare the size of the data. You can go for big data, NFS data and all. For one single month, you have close to 1,76,000 observations. Those observations EVs even not open. EVs are all very limited. It has a limited thing. It works for only a limited set of observations. If you have say 10 lakh observations, even Excel won't open. Excel have only 32 lakhs of columns. Sorry, 32,000 columns and 64 something. It's only that matrix. So you have such a big data, EVs and all won't work. You have to go for this hybrid, this this coding system. You have to declare the memory. If you have some 10 lakhs observations, the EVs won't open. Your geometry, your nothing will open. You have to declare your own memory. Maybe R or Stata will help. Stata have a big data set. That is what if you were dealing with panel data, they prefer. It's those who are working on time series models, they prefer EVs, but still I'm not much comfort with, even the initial days I also start working with EVs only, but now I'm little uncomfort with EVs because we don't know how it operates. Okay. Even though we have a problem, we don't have a solution. Even though EVs have that menu-driven, command-driven program, still the codes are not good. Even there is a forum called EVs also. I forgot the name. Forum.evs. You can get the codes, but most of the time it won't work. But Estima, you go and check. If somebody wants to work on Stata, you just go and see. They'll give all the models, the codes for all the models. It will help you to understand the things in a better way. Okay, right, fine. That is the reason why people are preferring Stata, ma'am. The thing is, you can declare your memory. You can for big data set, okay, huge data set, EVs won't support. So as I told you, we understand that there is a problem of autocorrelation, serial code. How do we address that? These are the tests. If you're dealing with fixed effect model, you can use Woolrich test. If you're dealing with random effect model, you can go for Balaji WLLB test. Then if you're using with dynamic panel, you can go for bond test. You may ask a question why it is. Even some of you may come across in time series also. If you're dealing with a stationary property with threshold value, your normal Pili-Poron test or ADF test won't work. You have to go for some more models, right? So it's all model specific. Okay, if this is the case, how we can correct the autocorrelation? You can't estimate the model as it is, right? First thing is there are certain setups, model specific setups. See, most of the time, this issue is related to errors, right? Instead of, for that, you have to understand the distribution of errors. There are different types of distributions are there in the error. That's what we are going to see. It is called as cumulative distributed function. So the error term may follow a normal distribution, it may follow a binomial distribution, it may follow a, what is that? Logistic distribution form on down. So what you can do is, if you feel that there is a problem in your errors, there is a autocorrelated errors, instead of checking the normal errors, there is something called as cluster robust standard errors. This model is available in Stata. It's a small command. So what you're going to do is you are going to declare to the system that you estimate my model with, instead of normal errors, you estimate with cluster robust standard error. Means this error will taken care of your autocorrelation problem in the fixed effect model. Right? I'm talking about how to solve it. This test or help you to identify it. Teacher is here. So
Welcome.
okay, give me 2 minutes.
Am I so disturbing?
No, I got tensed. Okay, suppose if you have a problem of autocorrelation random model, then you can try to estimate that with the AR term in your model itself. You can use AR1 terminology, then you can try to solve it. There are a few more tests. These names are a little strange. So the question is, among this, which one you're supposed to use? All depends upon you. Okay. What I'm suggesting you is you can go with all. When we can call a model as best model in the sense, even though you test with all the possibilities, if you give the same results, then only your model is reliable. If you test the data with 10 observations, you give one results. If you test with 11 observations, you give the different results. That model is not reliable. Okay. But getting the point, the results must be invariant of pattern or time. So if you test with all the parameters, if you give the same results, then that model is reliable. If you give the different results, then that results are model specific. It is not systematic. It is not fundamental. Okay. You have to make sure that, in my suggestion, you can test all. You have a look whether everything satisfies, everything given the same results or what. Accordingly, you can decide. So these things are only for static panel model or simple panel model. Suppose your estimations is around dynamic model, then you have to think about these two final measures. In the dynamic panel model, you can't apply cluster robust standard errors. You have to use either robust covariance matrix estimates. Okay. So where can you find this? Is everything is available in Stata, one single command. Okay. Only one thing is you have to know what context you have to apply this. Right? Any questions? Maybe remembering this is a little tough. If you start reading research papers, people are talking about this in a very detailed way. Okay. So how do we know it's only coming from reading? Reading empirical papers only give you the idea. So suppose if you want to solve the dynamic panel models, you also tried with lagged dependent variables also, right? These are some of the tests available for identifying serial correlation and solving the problem of serial correlation. Clear? Any questions? Because I'm moving to the next problem. Heterogeneity. So this topic I have to cover 3 topics. In this lecture, I have to cover 3 topics. One is heterogeneity, another is serial correlation, another is endogeneity. So even though everything looked like a unique issue, but everything has strong interconnection among themselves. Right? Endogeneity. So if you want to talk about endogeneity, let me start with the same time series econometric. Here also we have the same assumption, right? I think all of you know about what is called simultaneous equation models, right? As of now, what we saw is just one single equation. Maybe one dependent variable and one independent variable, but we are not discussing about a system of equations. What is a system of equations? System of equations is something which studied the entire system as a whole. For example, I think all of you are economic students, so you know that Keynesian consumption function, Keynesian equation function, right? We have 3 variables in the model. One is consumption, another one is investment, third one is income. We used to write consumption is the function of income, investment is the function of income as well as the past income. Investment is a function of past investment and income. Income is a function of consumption. investment plus government expenditure. This is the system of equation. If you estimate only first equation, then it's going to be a single equation model. But if you're estimating all equations all together, all three equations, I'm talking about time series. That's what I'm not given here. If you talk about all the three equations together, then it is going to be called as simultaneous equation model. Right? So we have a problem of something called as simultaneous equation bias. You know what is that? What is meant by simultaneous equation bias? Simple. If you have an equation which belongs to simultaneous equations, which means that I already told you about endogenous variable and exogenous variable, right? Suppose you have an
Feedback.
equation.
Feedback loop, reverse causality.
Yes, feedback rule, reverse causality. Fantastic. See, simultaneous equation bias is a problem. Suppose you have a set of equation where your endogenous variable means dependent variable act as one of the variable act as endogenous variable in one equation. The same variable may act as an independent variable in some other equation. If in such situation, if you are applying OLS to this setup, then you end up with the problem called as simultaneous equation bias. Are you getting the point? I'll tell you a small example. I'll give you two variables, quantity and price. What may be the functional form of this? What may be the equation for this? What may be the model? Quantity and price. I'll give you two variables, quantity and price. I'll ask you to estimate a coefficients. You're estimating a coefficient. What coefficient it is? What is a function of price you're estimating? You get one coefficient. What coefficient it is? It's a demand coefficient. It's a demand equation or supply equation. Anything. Here we can't conclude anything. Because if you want to understand that, we need few more information. If this kind of variables, quantity into price, if you estimate that, if you apply simple OLS here, you end up with the problem of simultaneous equation bias, because if the price is also influenced by quantity, demand, and some other equation. So there may be two-way causality. X is causing Y, same way Y is causing X. Then we have the problem of simultaneity. Okay, clear? In public finance, I can tell you, since Madam is here, she only taught us this public finance. There are a very famous theory. You know, what? Wagner's law of public expenditure. I think all of you know about it, right? What is Wagner's law of public expenditure? This is an example of what I'm going to convey for this simultaneity. Wagner's law of public expenditure. Wagner, German economist, used to say that if you want to achieve more growth, you have to spend, expenditure must be high, right? Your growth is a function of your public expenditure. If you want to spend more, you must have more growth rates. Are you getting my point? If the state want to spend more, public expenditure is a function of growth. If the state is spending more, means they have achieved already high growth. That is the point. But when it comes to Keynesian economics, Keynes says that if you want to achieve growth, you have to spend more. It's ulta, right? Here in the first case, your growth is public expenditure is a function of growth, whereas the second equation, Keynes says that growth is a function of public expenditure. So if such a setup, if you apply OLS to this, you end up with the problem of simultaneous equation bias. So if this is the case, you can't apply OLS. For this, we have a different setup called as simultaneous equation model. That is time series. In simultaneous equation model, we have a set of models. I'm not going into that since it's the panel data. So how this thing will happen? It happens through the correlation between the error terms and the regressor. Okay. We talked about this already. This is something like X2. Correlation between the X is nothing but your independent variable or exogenous variable, or endogenous variable. If the relationship between these two is not zero, then we have the problem of simultaneity. It leads to the problem of endogeneity, right? We're getting the point. What it means that one variable in one equation is associated with the other variable through the error term. We're getting the point. See, what is the error term? Error term will capture the impact of the variables which is not included in the model, right? So if you are not including the one variable in the model, that impact will be replicated in the error term. Okay. So if you are using the same variable in some other equation, this error term doing that variable. So there is a strong interconnection. Somebody said it's a feedback rule, also called as simultaneity. That is the case. Whatever estimates you are estimating is not reliable. It is biased. So in panel data, if we have a problem of simultaneity, how to endogeneity? Here we are using the term called endogeneity. How to solve that? So what are the problem? What are the reasons behind endogeneity? we all know the same thing. See, if you leave any variable, it's going to be it's going to create the problem of errors in variable. The same time, it's going to cause autocorrelation here. Dependent variable bias. If you leave one important variable in the model, which is influencing the dependent variable, but if you deliberately or without your knowledge you excluded it, that will influence your error term. Because of that, there may be a problem of endogeneity. Simultaneity, I already told you. There are two variables. See, in this equation, we are talking if this is the equation, you can apply single linear regression model, but it is not the case. X is also a function of this case, you can't apply this thing. If you apply so, you have the problem of simultaneity. See, what happened in this equation, you are leaving the impact of some other variable. Okay, that influence will be captured here. So since your x is the function of this u, x is equal to this. You have a problem of simultaneity. Right? Then this is for only for simple panel data. Suppose you have a dynamic panel, then you have something called as measurement error. Measurement error we already discussed, right? Then the sample selection. Suppose certain models are supposed to apply for a macro panel, right? But you are applying those models for micro panel because of the data structure itself. It needs to simultaneity. There may be a lot of reasons. The primary reasons is this omitted variable bias and simultaneity. Because of that, you end up with the problem of endogeneity. Why endogeneity matters? See, for all the problems, the end solution is you are going to get the biased results. I told you if you estimate a model, you pick a model for forecasting or policy purpose, you have to make sure that that model are error free. So it is not decided only based on one single coefficient. It's not decided based on one single parameter. We have to check all the possible parameters. You can't call a person very healthy based on only his physique. Okay, it's also based on a lot of other parameters, right? HbC level, BP, sugar, so and so. Okay, then only based on that only we can say a person is healthy or not. Looking at his physique, we can't say whether it is healthy or not. In the same case, if you want to decide a model, if you want to use the model for forecasting purpose or any policy suggestions, you have to check if the model is free from errors. So for that purpose only we are using serial correlation. For that purpose only we are using heterogeneity. The heterogeneity is also having the same purpose, right? So same slides. So how do we identify endogeneity? First thing is, I told you most of the things coming from theory. So if you try to estimate the Keynesian system of equations, you all know that your income act as a dependent variable on one equation, the same income act as an independent variable in some other equation. This is the case if you are going to estimate such an equation, you can't simply think the problem of endogeneity. Endogeneity exists in the model itself. So from the theory you can understand. Second thing is there are certain tests. Osman test, Darwin W, Olsen DWH test. Tell you how to identify endogeneity. How do we identify endogeneity from this test? For that, I need a data which have the endogeneity problem. Only it will help you. I'm just showing you what the things are available for your knowledge, right? Unstable coefficients. Sometimes unstable and maybe over-inflated coefficients. You all know that according to Keynes, the barrel supposed to consume value must lies between 0 to supposed to be greater than 0 but less than 1. Suppose you're estimating a model, the barrel supposed to be consumed says 2.5, then you know that there is a problem. Okay, getting the point. You're estimating a model, but the coefficients are completely unstable. It is not going with the theory. Then you may suspect that there may be a problem of endogeneity. Okay. So how do we solve endogeneity? There are very simple methods are there. Generally, what we used to do is that method I'm not giving. It's a simple process. Suppose you have a set of variables, say one dependent variable and set of independent variables. What you can do is you just remove the dependent variable. Okay. Keep one variable as an independent variable and estimate the model. That's the error term. Then use this error term in the original model. If that error term is significant, then you have the endogeneity. Getting the point. You have a set of variables, say 3 variables, x, y, and z. Okay, you are estimating X, Y, Z, and let me call it as income, consumption, price, and then output. There are 4 variables. For estimating income is a function of consumption, price, inflation. You just estimate a model, right? Then just leave income. Estimate consumption is a function of price and inflation. Get the error term of that model. Use this error term in the original model. If that error term is significant, then you have the problem of entropy. This is the easiest way of identifying things. Apart from this, the most formal way is instrumental variables. If you have a problem of endogeneity in fixed effect model, how can you solve it? You can solve it with the help of instrumental variable. What is instrumental variable? I already told you. The variable is called as instrument when it has a strong correlation with the dependent variable, independent variable of the model. At the same time, it is supposed to have the minimal or least correlation with the dependent variable. Then it is called as instruments. Generally, identifying instruments is a very toughest part. So generally, we used to use the lagged values, right? Maybe in the simultaneous model, you can understand the lagged values of a particular variable are also called as predetermined variables. If somebody studied there is econometrics, especially simultaneous equation model, we have something called as predetermined variables or exogenous variable, which is something completely out of the system. So lagged regressors. If you're using the lagged values of that or instrumental variables, that will help you to solve endogeneity problem in fixed effect model. There is something called like Chamberlain device model. It is also called a CRA model. It's all highly mathematical. Even computing that is very difficult manually. These models are accepted in the literature as a model to check the presence of endogeneity in a random effect model. It was proven. How do one will come with proposing the model? That is something called as iterations. If you want to propose a model or in the empirical literature, you have to check it for different purpose. It's supposed to be checked with different purpose. Everywhere it's give the same results. Then only that model come to life. There is a term I can tell you. This model, CRE model, is one among the model which will help you to solve endogeneity problem in a random effect case. Okay, it is not for fixed effect case. The same thing, Hoffman-Taylor specific estimator and instrumental variable will help you. In both the cases, you can instrumental variable, but you can't apply Hoffman-Taylor estimation for fixed effect model. If you have a model, fixed effect model, you have a problem of endogeneity. If you identify two, there are the other things. Then if you want to solve it, you have to use any one of them. Okay. The third term is called as stimulations. If you want to give a result which is accepted, you can have a data set, different dimensions. Maybe 1 lakh of data, we can keep on changing the data and keep on estimating the same thing again and again. If the coefficient is not changing, then the method is called as stimulations. All the model was stimulated, and it was provided. Okay. So some of the issues for your this lecture is over. Morning lecture is over. The first session is over actually. We started very late, man. Half an hour is gone. So 40, I covered only one part. So what I can do is I can cover the second part also, but not fully. Maybe 70% I can cover because the rest of the parts have a lot of equations. You're supposed to draw. Till time is 12:30. If you're ready to spare 1 hour, 1.5 hours, I can cover everything.
If they have any questions on this, we can take. But
anyway, questions?
Sir.
Yes, please.
First of all, good afternoon, sir. Sir, thank you, sir, for giving such an informative lecture. Sir, I want to ask a doubt regarding which serial correlation test is better.
See, that's what there are certain serial correlation tests are available for certain models. For fixed effect model, I gave you some list, Ulrich and all. For random effects, we have something called Hansen and LFS test and all. So these are some of the popular tests I'm suggesting. So it depends upon what type of model you are using. If you are using fixed effect model, there are certain specific tests are available for it. You can't use the test available for random effects for it. Generally, for fixed effects, you can go with Ulrich. That's the best choice.
Okay,
even
sir.
computational model is very simple.
Thank you, sir.
Questions? The slides what I'm having for probability and logic model is purely look like time series only. The last part are only for panel data, but maybe I can cover this. I can explain what are the things as much as possible because those things are a lot of equations. I have to use my and
You can cover, so like you can 30 minutes, 40 minutes. you can-
I don't know how much time it will take to cover this itself.
I mean, it's up to you. How
Okay,
much
fine.
you
Then we can.
cover.
The other this person is supposed to not disturb. No, if it's prolonged such a.
No, just a lunch break. We'll stop at 1:15.
Okay, man. I'll see.
If they don't have any.
Any questions, please?
No questions, we'll go ahead. This one is sir.
Yes, RCE models. We actually, as of now, whatever we discuss is completely different from this. Okay, these are the whatever operational procedures we are following for estimating our models as of now. Something different from this. I don't know how many of you are aware of longitudinal probit models. No, because without knowing this, there is no point in applying in panel models. So what I do is I can go for a basic revision of all these things. What is logic model? What is probit model? That is one more model called a probit model. So why these models are very important in the sense, because as I told you, maybe I can make in one single line, I can explain you how these models will differ from whatever we discuss. As of now, we discuss about fixed model and random effect model. Okay, these models are linear in parameter. Linear in parameter. Okay, it's like something like this. Distributional pattern of these models are linear in parameter, whereas longitudinal probit models and Tobit models, it is also called a discrete choice model. Okay. DSC, discrete choice models. These models are supposed to be estimated with non-linear models. You can't apply OLS for this. You have to apply maximum likelihood method for this. Okay, so it's a completely different setup. Just keep in mind. Okay. First of all, what we used to do is, as of now, as economists, what we're trying to do is we are always trying to conduct the relationship between the variables. All those variables may be or quantified. We can pick price data, we can talk about consumption data, we can talk about income data, about inflation data, exchange data, so on so. But in social science, the very interesting part is there are certain things, things which cannot be quantifying in nature. It is qualitative in nature. Okay, the point. There are certain characteristics or qualitative in nature. Alcohol consumption is not determined only based on income. It also depends upon nature of